Okay, I wanted to do a three variable system of three equations. Hopefully, this has one unique solution. I'm pretty sure that it does. And I wanted to do these using matrices. This we might not do it the most efficiently every single time, but we're gonna write this system as a matrix. We're gonna get it into row echelon form, and we're gonna solve from there. So, let's take a look. We make the matrix 4, -1, 3, and 6. So I hope we realize that those are just the coefficients on x, y, and z respectively, followed by the value that these 4x minus y plus 3z is equal to. Do the same thing for the second row. And for the third row, and make sure when you do this you put in the 0 for that third equation that doesn't have a z term. Do not forget to put in a 0 there, otherwise your matrix gets all messed up. So we can do three things. We can do three actions. We can either just switch entire rows, not columns. You can switch columns in other contexts, but this is not one of them. So we can switch entire rows. We can multiply an entire row by a constant. Entire row by and I should be more specific, a non-zero constant. Or lastly, we can add rows together. And most of the time, in fact, the most common thing we're going to do is these two together. We're going to do them at the same time, but that's fine. So we're often going to add rows and multiply an entire row by a non-zero constant. So remembering, we're trying to get it into row echelon form. So row echelon form will look like this. We'll have 1, 1, 1, 0, 0, 0, and I'll put dots for just, something. I don't know what those dots. I'll put question marks. Heck, that'll work. Anything, 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 anything. So we'll find out what those are, but we're not trying to control those. Those are just going to happen, and the things we're really trying to enforce is we're going to try to make that main diagonal top left to not quite the bottom right, but almost try to make that all ones and try to make everything below and to the left of it zeros. Okay, so that's the goal. That's what we're striving to do, and hopefully at the very end we'll take a look and be like, ooh yeah, if we get it into that form, it makes the equations really easy to solve. So here we go. First thing, chances are most of the time we're going to keep that first row exactly the same. We're going to keep it exactly the same. You could switch these and keep a different row the same, but for now let's just keep this guy here. So we're going to get 4, -1, 3, and 6. And actually I'm going to move these over because I need a little bit more space. 4, -1, 3, and 6. Now, this second row, the thing I'm trying to impose is I'm trying to get a 0 there. I'm going to write it in because I'm so confident that I'm going to be able to do it. And the way we're going to do that is we want to think, all right, what could I do with 4 and -8 to get them to add to 0? All right, well, I need to double 4. I'm going to double this 4 and then add it to -8, because if I double 4, I'll get 8 plus -8 will get to 0. So that means the rule that I'm going to impose on this second row is it's going to be 2 times row 1, and row 1 is referring to this entire row right here, plus just row 2. And I'll even do it in a different color. Let's see, we'll do it in purple, plus row 2, and by row 2, I mean that entire row 2 here. And this is going to become my new row 2. Okay? So the row 2 in the matrix that I'm currently working on. So we do have to do some mental math here, and I'm going to talk you through it, but hopefully, you can pause me and be like, did that mental math actually make sense? So we're going to do 2 times -1 plus 3, which would get us 1. Because 2 times -1 is -2, plus 3 is 1. We're also going to do 2 times 3 plus -5. Well, that's also just 1. Ooh, how convenient. This is turning out to be very nice indeed. And then, lastly, we need to do 2 times 6 plus -6. So 2 times 6 is 12, plus -6 is 6. It's a lot of 6s. All right, pretty good. Now, this next one, we're trying to still impose a 0 right here. We're trying to get a 0 right there as well. And I'm going to try to do it with rows 1 and 3 now. So I'm going to erase some things just to clean this up. Erase that guy. Well, I'm not going to do that. Sorry. I'm just going to erase from here to here. There to there. Okay. But for row 3, our new row 3, what I'm thinking of doing is multiplying the top row by -5 and the bottom row by 4. And that's because if I do -5 times 4 plus 4 times 5, I'll get 0. And that's really coming from just looking at this number and thinking, all right, what can I multiply each of them by so that I can then add these two things and get 0. And obviously, there's a million answers. There's actually an infinite number of answers. There's more than a million, but you want to keep it, on the small side. So here we go. We're going to do -5 row 1. Undo. So -5 row 1. And row 1 is still this thing up here. Plus, I think I stopped when I was saying plus. I accidentally hit the button and then, it paused my video. But that's okay. Plus, and I'll do this in blue, 4 row 2. And row 2 is this whole thing. So try to ignore, row 3. Row 3. Try to ignore that previous row 2. Okay, and this is what is going to become our new row 3. All right, so it's getting a little messy, but we're going to work with it. So we have -5 times 4 plus 4 times 5. That's 0. That's what we want. Now we're going to have -5 times -1. That's 5. Plus -4 times 4. That's -16. So 5 plus -16 is -11. And then this last thing, we're going to have -5 times 3, so that's -15, plus 4 times 0. So we're just left with -15. Okay, so more experienced pre-calc students. Oh, we're not done. Sorry. And then lastly, we're going to have -5 times 6, so that's -30, plus 4 times -9, which is -36. So -30 plus -36, so that is -66. And so here that goes. So -66. All right, so that's okay. I think if you're looking at this, it's not too bad. I'm going to just redraw it down here because we're getting a little cramped. So I'm just going to write the exact same matrix we just had. 4, -1, 3, 6, 0, 1, 1, 6, 0, -11, -15, -66. And I'm looking at this, and now we're getting pretty close to row echelon form. The only issue is, we need a 1 and a 0 here, and we have a -11, so that's not going to work. So I want to do two things at once. So the first thing I want to do is make this top row be led with a 1. So we're going to do it over here, and we're going to say 1/4 of row 1 is going to be our new row 1. So that arrow is going to become the new row 1. So that's going to leave us with 1, -1/4, 3/4, and 3/2. Just applying 1/4 times 4, 1/4 times -1, 1/4 times 3, and 1/4 times 6. Row 2 is actually kind of in the form that we need, so we can just leave it as 0, 1, 1, 6, 0. Oh no, I pressed erase instead of draw. 0, 1, 1, 6. Okay, great. Now, this last thing, I need to somehow get this term. So this one's going to be 0. That won't be too hard to do. But I need to make this one 0. So it's not 0 yet, but we need to do it. And the way we're going to do that is think, all right, what can I multiply 1 by and then add to something times -11 to get 0? Well, I could just multiply 1 by 11. add it to negative 11, and get 0. So, I know I'm talking fast, but I don't think that idea is particularly confusing. So we could do 11 times row 2 plus row 3, and that's going to get us our new row 3. All right, and if you're sitting here thinking like, oh my goodness, why on earth are we doing all this? That's a reasonable feeling right now, but trust me, it's going to pay off. So we do this. We do get 0 because, 11 times 0 plus 0 is 0. 11 times 1 plus negative 11 is 0. Now for this next one, we're going to have 11 times 1 plus negative 15. That's negative 4. So put negative 4 right there. And 11 times 6 is 66 plus negative 66. That's nice. That's going to just go to 0. All right. So we're going to get 0 here. We're almost in row echelon form. We just got to do one thing. We're just going to take this third line and multiply it by negative 1/4. But I have to be thorough and make this 1, negative 1/4. 3/4, 3/2. So first row is exactly the same as it was before. Second row is 0, 1, 1, 6, exactly what it was before. And this third row, we're going to do negative 1/4 of row 3, and that's going to be our new row 3. And so it's always, in here, I say as though that's helpful at all, but right here is always referring to the previous row 3. And then this one right here is the new one, what we're going to put in there. And that's going to get us 0, 0, 1, 0. Now, strictly speaking, when it comes to actually solving anything, this step was a bit silly and unnecessary. It doesn't really give us any new information. But to technically be in row echelon form, this is what we need to do. And we've done it. We are in row echelon form. Excellent. So we're going to then take this and write out the equations that this implies. So it implies the following equation: x minus 1/4 y plus 3/4 z is equal to 3/2. Y plus z is equal to 6. Z is equal to 0. So hopefully you can see the connection from there, there, and there. And at this point, I'm going to leave it to you because you're in pre-calc and you don't need any help with this anymore. Z is 0, plug it in. That means y is clearly 6. So if that's, and I think that's going to mean x is, looks like 3, but I'm doing that in my head, so that might be wrong. Do it by hand and check it on your own. And that's how we do it. All right, so the goal is to get it into this form. And sometimes it takes a little bit of time, but that's how we do it. All right, good luck.